This instructional video is designed around the idea that we use the weighted average a lot in chemistry. We have things like Dalton's law of partial pressures, which is a weighted average. We have our isotope ratios for determining the average atomic mass of things, which is a weighted average. And you know, it would be really useful is if I had a mathematician to really explain it to you, since it is basically a math thing.
Did somebody call for a mathematician? Well, here I am. My name is Dr. Talitha Washington, and I love mathematics. So today I will give a brief explanation about how to find a weighted average. Every student loves to calculate their end of semester grade. I will give you the secret on how to do it. So let's say in your class you're assigned a final exam weight of 30%. And let's say your professor gives the semester grades a weight of, the semester exams a weight of 40%, and your homework weight is 30%. So note that in this case, 30 plus 40 plus 30 is 100%. When we have a weighted average, it assigns a different value, a different emphasis to different components in a data set. In this case, we have three components in our data set. One is final exam, another one are the semester exams, and the third one's our homework. So let's say I'm a very studious student, and I score, let's say in my final exam, I earn a 90. That's my final exam grade. And so let's say that, so that's my final. Let's say my exam average, I calculate that to be an 85. And I love doing homework, so let's say my homework average, it comes out to be 100%. So what I need to do is I need to take three components and do a weighted average. What I will do is take this final grade, multiply it by 30%, plus the exam grade, multiply it by 40%, and then the homework grade and multiply it by 30%. And in that case, I'll have my wonderful end of semester average. So a nice way to do that is the following. Over on this side, let's write out what this is. So I take my final grade, 90, and multiply that by 30%. Now remember, 30% in decimal, we move the decimal place 2 places to the left, that's the same thing as 0.3. So I'm going to write these percentages as decimals. So I'm going to take 90 times 0.3 plus, and then I'm going to take my exam score of 85 and multiply it by 0.4 plus my homework score of 100 and multiply that by 0.3. And now I just need to add up these three terms. So remember, order of operations, everybody loves Aunt Sally. We do the multiplication first. So first we want to calculate 90 times 0.3. So 90 times 0.3, that, remember 9 times 3 is 27. And then notice we can think about this as 10 times a 10th, so that kind of cancels to 1. So that product here is 27 plus. Now 85 times 0.4, that's a little bit tricky. So let's go ahead and write out that multiplication. So 85 times 0.4. So 5 times 4, that's going to be 20. 8 times 4 is 32. Plus 2, that's going to be 34. And note we want to move the decimal place over to the left of 1. So 85 times 0.4, that's just going to be 34. And 100 times 0.3, we move the decimal place over 2 places to the right. So we want to add 30. Now we just want to add these three numbers together. Let's take 2 at a time. Addition is binary. So adding these two, 7 plus 4, that's going to be 11. So I put the 1 here, and then I kind of cheat and put the 1 there so I don't forget. 3 plus 2, that's 5, plus 1 is going to be 6. Don't forget we still have to add on the 30. And lo and behold, my end of semester average is a lovely 91. And I'm feeling pretty good about that A. I worked really hard. So in sum, if you want to find a weighted average, as long as the weights add up to 100%, you take each of the weights and multiply it times the value. The way we write that mathematically is that we write the sigma for sum, we take each of the weights, W, and we'd like to put a little I because they could be different, times each of the numbers X sub I. And this is how we would write it in condensed shorthand form. So now you know how to calculate your weighted averages, and everybody loves math.
Oh, well, there you have it.